This lesson looks at equivalent ratios. As we work with equivalent ratios, it's important to understand what an equation is. And an equation is a statement that two things are equal. We can use an equation to show equal ratios as well. That means the ratio on the left side of the equal sign needs to be equal to the ratio on the right side. And if you look at the examples here on the screen, they should look familiar to you because they look like equivalent fractions, and we've worked with those quite a bit. You know that 9/6 is equal to 3/2 because we can divide 9 by 3, and we can use that same factor to divide 6. If you look at the other three examples, we've used multiplication to show those equivalent fractions or equivalent ratios. Sometimes a double number line is helpful in understanding the equivalent ratios for a situation. In this situation, we're talking about a pair of gears, and we're talking about the ratio of the gear rotation being 1 to 2. That simply means that this larger gear is going to turn one complete circle, 360 degrees. And every time that large gear turns one full circle, the smaller gear is going to make 2 revolutions. It's going to turn twice. So that's where the 1 to 2 ratio is happening. And we're being asked to write 4 equivalent ratios for this 1 to 2 rotation. On the double number line, you see on the top we have started at 0, 0, or started at 0. And then our next mark shows 1, and that represents the first number in our ratio. On the lower number line, where we start at 0, we're moving over to 2. So that represents the 2 on the second part of the ratio. So now you can see our initial ratio, that 1 to 2 ratio happening here. Now to move down this number line, we can think about what factors use to go from 1 to 2. That means we're multiplying by 2. We use the same factor below to multiply by 2, and that gives us 2 over 4. So that's our next equivalent ratio. We can use the same factor over and over if it makes our work easier to manage. We'll do 2 times 2 to get 4 here, and now we'll do 4 times 2 to get 8. So there's our second equivalent ratio. We're doing the multiplication again with a factor of 2. 4 times 2 is 8. 8 times 2 is 16. There's our third equivalent ratio. And then one more time we're multiplying by a factor of 2, and that's giving us the fourth equivalent ratio to 1 to 2. And so on the double number line, you can see every one of these equivalent ratios show up one after the other. Okay, let's work through a few problems together just so we can get comfortable with the idea of working with equivalent ratios. On the first one, we're given a ratio of 4 to 5. We're asked to write 3 ratios that are equivalent. So we can use the same idea that we just saw on the double number line. We can set up 4 to 5 as a fraction if it helps you. And let's just multiply both by a factor of 2. 4 times 2 is 8. 5 times 2 is 10. We have 1, our first equivalent ratio. We can just keep that multiplication going. We can say 8 times 2 is 16. 10 times 2 is 20. Oops. And we have our second equivalent ratio. One more time of multiplying by 2, we can get 32 over 40. And there's our third equivalent ratio. So it can be just as easy as as simple as using the same factor over and over. Always evaluate before you start doing that, though, because sometimes the work is a little easier if we simplify. So let's take 14 to 28. Well, I know right away, since they're both even, these two numbers have a factor of 2. So I can use division this time if I choose. I can use multiplication, but this will make it a little easier to handle. 14 divided by 2 is 7. 28 divided by 2 is 14. That means 7 to 14 is equivalent to 14 to 28. And then after I finish that, I see that 7 and 14 have a common factor of 7. So that means 1 to 2 is equivalent to 14 over 28. And 1 to 2 is in a simplified form, so I'm going to have to go back and use a little multiplication now, but that's okay. I can take 14 28ths. I can multiply by 2 this time, and I'll get 28 over 56. And there is my third equivalent ratio. So you can see in this example, multiplication or division can be used. Just use what makes your work easiest. All right, in our third example here, I have 10 over 5. Hopefully you can see right away that we have a common factor of 5. So we can divide both by 5 and get 2 over 1. And now we can use some multiplication, and let's multiply by 2. And we will get 4 over 2. And then we can go ahead and multiply again and get 8 over 4. All of these are equivalent to 10 over 5. All right, the next three examples give you a pair of ratios and ask you to show whether they are equivalent or not. So let's start with 4 to 6 and 20 to 30. And the question is there a common factor that I can use through multiplication or division to get from my first number here to my first number here that will also work on my lower number? Well, I know that 4 times 5 gives me 20. So if I can multiply 6 times 5 and get 30, which I can, I know that I have a pair of equivalent ratios. All right, over here we have 14 to 7 and 15 to 5. Now, I don't have a factor that I can multiply 14 by to get 15 or 7 to get 5, but if we look at this, 14 over 7 will simplify to a ratio of 2 to 1. 15 over 5 will simplify to a ratio of 3 to 1. And if we look at these, we know that a 2 to 1 is not equal to a 3 to 1. So this pair of ratios is not equivalent. I should mark that here as well with the original ratios. Okay, finally we're looking at 3 over 6 and 10 over 20. And in this case, I can simplify both of these ratios. I know that 3 over 6 is equivalent to 1 over 2. And 10 over 20 is also equivalent to 1 over 2. So yes, they are equivalent. All right, in this particular situation, we are at the store where bananas are on sale for $3. Oops, let's try $3 there. $3 for 10 bananas. And the question is, what will it cost for 5 bananas? So you'll notice that I put my money on the top of the first ratio. That means the money has to be on the top of the second ratio. And bananas are the lower numbers for both. We have to have that consistency in our labeling. All right, so let's take a look at the relationship between 10 to 5. I know that in order to get from 10 to 5, I have to divide by 2. So in order to have an equivalent ratio, I need to divide $3 by 2 also. And that's going to give us $1.50 for the 5 bananas. All right, our last example involves a double number line. And we are told that chicken is on sale 5 pounds, so there's our first number in our ratio, for $8. And we're being asked, what will it cost to buy 25 pounds of chicken? So on a double number line, it looks like this. We're going to start at 0, 0. We'll set our first vertical line up as our ratio that we are discussing. And then we can use multiples of 5 on the top number line. And we'll multiply by the same amount for every time on the lower. So let's start with 5 times 2. That would be 10. So we need to do 8 times 2, which is 16. Then we can do 5 times 3, which is 15. 8 times 3 is 24. We need to work our way up to 25 pounds of chicken here. 5 times 4 is 20. 8 times 4 is 32. 5 times 5 is 25. And 8 times 5 is 40. Right here at the 25 pound mark, I know that the chicken is going to cost me 40 pounds. So our answer is going to be 25 pounds cost $40. So Make sure you have all the examples down. You've done a good job of taking thorough notes from the initial portions of the video. Don't forget the WSQ as you conclude your work tonight, and bring your notes into class with you tomorrow. Thank you.